Volcanoes. These majestic mountains are a powerful reminder of the raw, untamed forces that lie beneath the Earth's surface. They are windows into the heart of our planet, offering a glimpse into the incredible forces that have shaped our world for billions of years. But what exactly is a volcano? Imagine a sleeping giant, slumbering beneath the Earth's crust. This giant is filled with molten rock, burning with the heat of the Earth's core. A volcano is like a pressure valve for this fiery giant, a pathway for the molten rock to escape. When the pressure builds up, the volcano erupts, spewing forth lava, ash and gas in a spectacular display of Earth's raw power. These eruptions can be both destructive and creative, shaping landscapes and influencing life in profound ways. Join us as we delve into the fascinating world of volcanoes, exploring their structure, their behavior, and their impact on our planet. To understand how a volcano works, we need to take a journey into its depths. This journey will reveal the fascinating and complex inner workings of one of nature's most powerful and awe-inspiring phenomena. Imagine slicing a volcano in half, like cutting open a fruit to reveal its inner workings. This cross-section allows us to see the different layers and components that make up a volcano, each playing a crucial role in its activity. At the heart of a volcano lies the magma chamber, a vast reservoir of molten rock. This chamber is the source of the magma that fuels volcanic eruptions, and its size and shape can vary greatly depending on the type of volcano. Think of it as a giant underground cauldron, bubbling with molten rock under immense pressure. The magma within this chamber is a mixture of molten rock, crystals, and dissolved gases, all of which contribute to the explosive potential of a volcano. From the magma chamber, a long, narrow conduit called the vent acts as a chimney, connecting the molten rock to the surface. This vent is a critical pathway, allowing the magma to travel upwards through the Earth's crust. This vent is the pathway for the magma to escape during an eruption. As the magma ascends, it can cause the surrounding rock to fracture and create new pathways, further complicating the internal structure of the volcano. At the top of the vent, we find the crater, a bowl-shaped depression that forms around the vent. This crater is created by the explosive force of eruptions, which can blast away the surrounding rock and create a distinctive feature on the landscape. This is the opening through which the molten rock, now called lava, erupts onto the Earth's surface. The lava can flow out in rivers of molten rock, creating new landforms and dramatically altering the landscape. Together, the magma chamber, vent and crater make up the basic structure of a volcano. Each component is essential to the overall function and behavior of the volcano, and understanding these elements helps us predict and prepare for volcanic activity. However, not all volcanoes are created equal. They can vary widely in their size, shape and eruptive behavior, influenced by factors such as the composition of the magma, the tectonic setting and the history of past eruptions. They come in various shapes and sizes, each with its unique characteristics. Some volcanoes are towering symmetrical cones, while others are broad shield-like structures. Some erupt explosively, while others produce gentle lava flows. This diversity makes the study of volcanoes a fascinating and ever-evolving field. The magma chamber is the beating heart of a volcano. It is a dynamic and ever-changing environment, constantly influenced by the forces of nature. This subterranean cauldron is where molten rock, known as magma, accumulates under immense pressure. The pressure is so intense that it can cause the surrounding rocks to crack and shift, creating pathways for the magma to move. The magma is a mixture of molten rock, dissolved gases and crystals heated to temperatures exceeding 1000 degrees Celsius. These high temperatures cause the magma to become highly fluid, allowing it to flow and move within the chamber. Imagine the magma chamber as a giant pressure cooker, with the heat from the Earth's interior constantly heating the molten rock. The heat is generated by the decay of radioactive elements and the residual heat from the planet's formation. As the pressure builds, the magma searches for a way out, pushing against the surrounding rocks. This relentless pressure can cause the rocks to fracture, creating new pathways for the magma to escape. The size and depth of the magma chamber vary greatly from one volcano to another. Some chambers are only a few kilometers wide, while others can span tens of kilometers. Some magma chambers are relatively small and shallow, located just a few kilometers beneath the Earth's surface. These shallow chambers can lead to frequent but less powerful eruptions, while others are vast, extending several kilometers below the Earth's surface. These deeper chambers can store more magma, leading to larger and more explosive eruptions when they finally release their contents. The composition of the magma also plays a crucial role in the volcano's eruptive style. Magma can vary in its chemical makeup, which affects its viscosity and gas content. Thicker, more viscous magma tends to trap gases, leading to more explosive eruptions. This type of magma is often rich in silica, which increases its viscosity and makes it more difficult for gases to escape. While thinner, more fluid magma allows gases to escape more easily, resulting in gentler eruptions. This type of magma is typically low in silica and can flow more freely, allowing gases to escape without building up pressure. Section 4. The vent and crater gateways to fury. The vent and crater act as the gateways through which the molten fury of the Earth escapes during a volcanic eruption. The vent, a long, narrow conduit, serves as a pipeline connecting the magma chamber to the surface. Picture the vent as a giant chimney, channeling the molten rock upwards under immense pressure. As the magma rises through the vent, it expands and releases gases, further increasing the pressure within the volcano. At the top of the vent lies the crater, a bowl-shaped depression that forms as a result of previous eruptions. The crater acts as the volcano's mouth, spewing forth lava, ash and gas during an eruption. The size and shape of the crater can vary greatly, depending on the volcano's eruptive history and the type of magma involved. Some craters are relatively small, resembling a giant bowl, while others are massive, spanning several kilometers in diameter. Section 5. Rumblings and warnings, nature's alarm bells. The Earth is a dynamic and ever-changing planet, constantly shifting and evolving. One of the most dramatic and awe-inspiring events in nature is a volcanic eruption. But these eruptions don't just happen out of the blue. They are often preceded by a series of warning signs that, if detected and interpreted correctly, can save lives and minimize damage. Before a volcano erupts, it often provides a series of warnings, like a rumbling giant signaling its impending fury. These warnings can come in various forms, each one a clue to the impending volcanic activity. These warning signs, though subtle, can be detected by scientists using sophisticated monitoring equipment. This equipment is designed to pick up on the smallest changes in the Earth's behavior, allowing scientists to piece together the puzzle of an impending eruption. One of the most telltale signs is an increase in seismic activity around the volcano. This seismic activity is often the result of magma moving beneath the Earth's surface, causing the ground to shake and tremble. As magma rises within the volcano, it puts pressure on the surrounding rocks, causing them to fracture and shift. This fracturing and shifting can create a series of small earthquakes known as volcanic tremors, which can be detected by seismometers. These movements create earthquakes, which can be detected by seismometers. Seismometers are incredibly sensitive instruments that can detect even the smallest of tremors, providing valuable data to scientists monitoring the volcano. Another warning sign is ground deformation. This occurs when the ground around the volcano begins to change shape, often swelling or bulging as magma accumulates beneath the surface. As magma accumulates in the magma chamber, it causes the ground to swell and bulge, like a balloon being inflated. This deformation can be subtle, but it is a clear indication that pressure is building within the volcano. Scientists use tilt meters and GPS stations to monitor these subtle changes in the ground's shape. Tilt meters measure the angle of the ground's slope, while GPS stations provide precise measurements of the ground's position, allowing scientists to detect even the smallest changes in deformation. Volcanoes also release gases such as sulfur dioxide and carbon dioxide as magma rises within the vent. These gases can provide important clues about the state of the volcano and the likelihood of an eruption. An increase in gas emissions can indicate that an eruption is becoming more likely. The composition and quantity of these gases can change as magma moves closer to the surface, providing valuable information to scientists. Scientists use gas sensors to monitor these changes in gas concentrations. These sensors can detect even small changes in the levels of gases being emitted by the volcano, allowing scientists to track the movement of magma and predict potential eruptions with greater accuracy.